Hello everyone, my name is Keenan. If you're wondering my last name, Bolick Poling. It's a mouthful, but Keenan is great. Welcome to this recorded version of the Rhino Workshop series for the landscape architecture students. Welcome. You are maybe watching this for the second time going through this series. I want to be able to answer some of the common questions and address some of the workflow issues that we are having throughout the modeling of this sort of follow-along series. And this is going to be much more sort of at your own pace. So, you know, being a video, you can pause, rewind, come back to it as you see fit. Right off the bat, I just wanted to point you in the direction. We'll be using this outline for the modules. So we'll be kind of referencing some of the steps here if you want to follow along. So it's nice to have this PDF open as you're going through this follow-along series. So for now, I'll just put that over there. Okay, so go ahead and boot up Rhino if you haven't. Now, right off the bat, I am still using Rhino 7 on this machine. So some of the features may differ slightly between Rhino 7 and Rhino 8. I'll try to address those main differences and where they're similar. Also, if you're on a Mac, this is going to look a little different. I'm running Windows 11, and the interface is just a little bit different. So hopefully there's some enough similarity that you can find the tools and the settings okay. Okay, so with Rhino booted up, we're just going to open our intro file. So I'm going to go up to File, Open, and I'm going to navigate to my Chapter 3, What is Rhino 3D? So if you've downloaded that from the OneDrive folder that we have shared, go ahead and find that file location and open it up. It should look something like this. Okay, so our first topic, what is Rhino? So Rhino, feel free to explore this model as we go about. Rhino is a surface modeler. And what does that mean? As you're exploring this, you can right-click to orbit and zoom in and zoom out. That'll kind of give you a little starting point as I do this little intro. So a surface modeler is a piece of modeling software that, lo and behold, models volumes with surfaces. And it differs from other types of modeling programs like mesh modelers in that mesh modelers are more approximations of true 3D shapes. Meshes use a combination of points and triangles to define these planes that make up a complex surface. So we'll jump ahead over here just to our meshes. Rhino can use meshes and it displays them in this sort of tessellated way. So for instance, if we select the surface by left clicking, we'll see that it's made up of a bunch of these sort of flat segments. Those are those triangle meshes. Meshes are fine for a lot of things. They have their place in Rhino, but Rhino's native geometry that it uses to model is not mesh-based. It is surface-based. And it uses a kind of complex, fancy math to create those surfaces in very precise ways. If you see this sort of intro area here, we'll talk about what this means. NURBS, non-uniform rational basis spline. If you kind of zoom in, you can kind of see this image here. So this is the geometry language that Rhino uses. It's a way of mathematically describing curves that vary in a very precise way. And this comes from a very sort of analog process. In shipbuilding, this is an image of like some plans for the hull of a ship. This is still probably used today, but you know, back in the day before computers, people would generate these complex curves by just literally putting a spline or a piece of wood, in this case, represented by this line in Rhino, over a piece of paper and then holding it in place with these weights. And just the natural curvature of that flexible piece of wood would define a very complex shape, and you could control it by and moving these weights around and putting that piece of wood in different places of tension. So Rhino works the exact same way, and this is super cool. If you select this red line, you'll see these little nodes, and we'll talk about these a little bit more, but these are control points, basically a one-to-one mapping of how Rhino geometry is creating this curve and how it comes from a very analog method of drawing. So there's that sort of fun history. And if we go down a little bit, we'll see the surfaces are just sort of using that same approach for this NURBS geometry, this spline, but instead of just one line, it's many lines that go in both an X and Y direction, or in this case, a U, which is similar to the X axis, and a V, which is similar to Y. Those are just sort of relative coordinates to a surface. So it's using those X, Y, or UV lines to create an interpolation of surfaces in multiple directions. So why do we even care about this? This is the basis of all kind of modeling in Rhino, with a few exceptions, but this is pretty much always what you're going to be using to create complex volumes and geometry. And it's helpful to kind of know what the original ways of creating these are, because as we go further, we'll be able to manipulate these control points in both the line mode and the surface mode to create very precise and freeform geometry. So Rhino is incredibly flexible in this way. It allows you to create a lot of different geometry, and it doesn't limit you to a specific type of workflow. Okay, cool. So as we're sort of exploring this model, let's sort of zoom out a little bit, right? So that's what Rhino is. It's a surface modeler using this NURBS geometry. Okay, taking a big step back, let's look at our general viewport layout, our Windows layout. Okay, so at the top here, you're going to see some familiar set specs like file, edit, view. Then there's some other specific things like curve, surface. These are all ways that you can get more specific information and tools about those Rhino commands. Speaking of commands, directly below that file area, and on the Mac it might be a smaller box on the right side over here, but in Windows-based Rhino, you'll have this command line here. And this is where all of our commands will be entered into Rhino to draw a line or extrude a line or reorient the viewport, changing perspectives. There's a whole host of commands, and it's kind of like learning a language in a sense, except it is all fairly intuitive. For instance, if you wanted to draw a line, you would just type in line and then press enter. And that would prompt that line command. We'll get into that more specifically. Just wanted to demo what that command line. One note about the command line, this cursor is always going to be active. So even if I've been zooming around and selecting different things, I don't have to go and put my mouse up here. It's always kind of active. So that'll save you a lot of time as you're modeling, because sometimes you'll use a series of commands over and over again, or a series of different commands. So you don't have to always go back up there. It's always going to whatever you type in the keyboard is going to show up in that command line. Great. So below the command line, we have these other tabs. The main one you'll pretty much always be on is the standard tab. But then we have C-plane, set view, display, a bunch of other things over here. I think, for now, just keep the standard tab there active. Moving down a little bit below, on the the left-hand side, I think I said right-hand earlier when I referenced the Mac command line. On the left-hand side, you'll see the series of toolbars, and these are commonly used tools like the polyline, some 2D curves, that was used to generate this red curve, for instance. There's some basic sort of box commands that used to create volumes. There's a text object. So there's a whole bunch of commands over here. These are commonly used, either 2D and 3D geometry, and then some commonly used commands to manipulate that geometry. You'll notice on a lot of these, they have this little arrow that gives you, if you hover over it, it'll say cascade and then solid creation. So for example, if I hover over this little arrow, left click, you'll see there's a bunch of other commands that live within that sort of primary command. So in this sort of creating basic volumes, we've got the cube, or in this case it's the box, cylinder, sphere, cone. So if you're looking for a different command that's related to that top level one, for instance, under polyline, you'll find single line. There's our polyline, midpoint. There's a lot of different sort of specific ones under each one of these drop downs. So you can either left click that arrow to get that cascade, or you can right click and hold over that specific toolbar. So if I right click hold, then I get that kind of quick menu. That can just be a little easier than hunting for that tiny little corner. So yeah, right click and hold. Also, I suppose this would be a good time to mention, if you're not already using a 3-button mouse, I highly recommend that for all your Rhino modeling, and really get one that has physical buttons. Some mice, especially the Mac mice that have just like a one click and then there's like a smart sort of touch, those can be super finicky, and I don't recommend those. So, find a cheap $10 mouse at like online on Amazon or whatever, and it'll just save you so much time. And I know some people who've done amazing things with a trackpad on a laptop in Rhino. It totally blows my mind. That is just not how I learned, and I think I would recommend getting a 3-button mouse, left, right, and a middle scroll button that also can double as a click sometimes. So highly recommend that. Okay, moving along. After our toolbars over on this left side, you'll see, let's talk about this primary viewport that we've kind of been exploring. This is our view into the model, and there's many different ways that this viewport can behave. And there's several default presets that are common when you first boot up Rhino. Over here on the top left corner, you'll see the name of this viewport, it's perspective, and then you'll see this little drop-down arrow. If you click the drop-down arrow, you'll find a lot of different settings about what this viewport, how it can behave. Mostly, you'll be using these sort of top ones where it says wireframe, shaded, rendered. So for instance, if you open up a Rhino file, by default, it'll be in this wireframe mode. So everything just is like 2D lines and can be kind of annoying. I very rarely just use this display mode. These are called display modes. So you can quickly toggle those display modes by going to the drop down. I either do shaded, which is what we started with, or sometimes I'll even do ghosted. Ooh. And this allows you to see through an object, but you still kind of get a shaded volume. So that can be helpful sometimes. Not always, but a lot of the time. I know we've got some other ones like artistic is kind of fun. You'll notice it kind of renders out a little bit of shading. I've got some lights over here we'll talk about in a second, but yeah, it's there. What I'll often do is this basic rendered mode. If there is no lights, it's kind of nice. You can also do Arctic to get a sort of uniformly shaded sort of white render, sort of abstract kind of 3D shading without seeing all the other lines that help you see a surface curvature. So that can be kind of nice. So that's how you basically change those. We'll talk a little bit more about these as we go. So I'll put it back to shaded for now. Okay, so that's our primary way of changing viewport display options. Another way is on the standard toolbar. See this blue circle? We're not going to do that, but we're going to do the one just next to it. That's for rendering. We'll get back to that. But here's another way. You can see these similar display modes. You got wireframe, shaded, some other things. So either way, you can use that little drop down, or I think it's somewhat easier to come over here and get that little arrow. Okay, so this is our perspective, but that's not the only viewport. So if you double click perspective, double left click, you'll see it kind of pops out to this 4-view mode. These are default 4-view viewports, excuse me. You've got your top, which is your plan view. This is just a top-down projection. It's useful for drawing plans or seeing things from a top view. And you've got our perspective. We're pretty familiar with that. And then we've got our front and our right views. So the front corresponds to, in the perspective, it's like if you were viewing it right from this area here. So you're looking with the y-axis, this green line going away from you, and the red axis here going from side to side. So that's sort of how our front view is set up. And similar on the right-hand side, if this is our front view, then the right side would be as if it was projected flat like this in perspective view. So that can help you get oriented. Now you'll notice that these are in wireframe mode, display mode by default. So let's go ahead and change those. Now, if you want to change all your viewports to the same mode simultaneously, it's easiest to go up to this little gray sphere next to your blue thing. Go to the cascade view, and then you're going to see if you hover over this little first gray sphere, it's our shaded viewport. And then if you notice on the little hover pop-up, left button will apply it to the current viewport, and right button will set all viewport displays to shaded. So I'm going to right-click that sphere, and you'll notice both in the front and the right view will switch to that. So just to demo that for, like, say we wanted all of them in this Arctic mode, this sort of, I'll right-click that, and they all switch to that. So that's a fast way, instead of individually clicking. A lot of this workflow is just finding fast ways to do things. So I'll right-click the gray shaded sphere, so I set it all to shaded. And you can kind of see this a little bit easier, right? So the wireframe can make things a little tricky to see. But you'll notice, yeah, we've got our front view here, right view over here. Whichever viewport I left-click into, it will make that the current viewport, and it'll activate that viewport. And you'll notice whichever viewport is activated, it has this bolded sort of dark text and a blue sort of highlight. So that can tell you which viewport you're currently in. You can also activate a viewport just by orbiting in that. You see how it goes like from one to another? Orbiting again with right-click in perspective. If you right-click in top view, you'll notice it doesn't orbit, but instead it pans. You get this little hand that pops up. So this is super helpful if you just, because you pretty much want to maintain this like top view. You don't want to like distort it or orbit in top. That's what perspective's for, right? So, so we can use our hand tool to pan, and similar to the front and right, it's right-click is pan. If we want to pan in this perspective viewport, you're going to hold down Shift and then right-click. Then you can pan. So a combination of using the zoom wheel, the scroll wheel, zoom in, zoom out, and then Shift, right-click, and then Shift without right-clicking. Right-clicking without Shift to orbit. So that's your basic navigation. How do you get around these viewports? Okie dokie. Moving right along. I think to make a current viewport full screen, you just double-click the title. So for instance, double-click the title of top, and I can get this to be full screen. Again, double-click to go back to 4, and then let's go back into perspective. Double-click, make this full screen. All right, so now that we've talked about viewports, let's go down underneath the viewport. You can see these little named views. This is another way to quickly toggle between active viewports, and it makes it full screen right away. So many different ways to navigate those viewports. Under those like predefined viewport names, you'll see these sort of end, near, point, mid, blah, 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 blah. In Rhino 7, these are called O-snaps, or objects snaps. I'm just going to go back to perspective real quick. These in Rhino 8 are located on the left toolbar underneath this sort of default toolbar group here. So if you're looking for those, they're going to be in Rhino 7 at the very bottom, or in Rhino 8 along this left-hand side. And I think in Rhino 8 they even have a little label there, O-snaps. So O-snaps are used for creating snap points to various places of geometry that make other commands, like moving an object precisely from one point to another, much more easy. We'll get into that in a second. We'll do some follow along. So for now, I would recommend enabling end, point, mid, int for intersection, perp for perpendicular, tan for tangent, quad for an object's quadrant, knot, and vertex. Those are my defaults. I will also occasionally toggle center on, although that can be kind of a beast. Center loves to be the center of attention, so sometimes you want to snap to something that's other than the center, and it's going to be like, oh, you want to snap to the center. I am the center of attention. So I leave that off by default, but that's probably the one that I toggle on the most of these. So anyway, I would recommend having those on by default. Okay, moving right along, we've got other things like project. We'll get to that later. Disable, you can disable all of your O snaps at once if you don't want to be snapping to a specific spot. I rarely do that. There are times for it, but okay. Farther down at the very bottom here, and I apologize if this is different for Mac. I'm not as familiar with that user interface, so if this is wildly in a different location, please bear with me. We're trying to make it all work here. So just below that, you'll see this sort of teal color, and then it says box. And this is our layer quick select tool. So if you click that where it says box, you'll get a pop-up of all the current layers in the project. And this is just a really quick way to either change an object to a specific layer or change your current layer. I'll talk about this in a little bit, but you'll notice under the box, there's this little check mark, and that says, this is my current layer. So any geometry that I create on now will be assigned to this box layer. And you can just kind of tell it'll show you that current layer here. To the left of that is our units for this model. We are in inches currently. Moving along, we've got these are sort of these global parameters of our project, like grid snap, whether objects that we move are snapping to a world grid or not. I tend to have that off. Ortho, this will snap lines to the cardinal directions at 90 degrees. I think it's handy to have on, but you can toggle this on and off. Planar is another handy command. It just keeps lines that you draw on the same plane by default, rather than going up and down to different heights. So I think that's handy to have on. O snaps, again, that's another way to disable them. You can toggle that on and off, see that. I usually have them on. Smart track, we'll talk about that a little bit later. I would have that on by default. And then gumball, I would have this on by default. Just to demo what the heck is gumball, let's go over here to our little world of basic shapes. Go ahead and select this cone. And you'll notice you have this green, red, and then if you orbit, you'll see this blue arrow and all these other things. We're going to talk about gumball later in more detail, but this is what the gumball is. It's a way of controlling and moving an object really precisely. You can click and drag these arrows to move it around. We'll get to that in a second. But if you select an object and you don't see this gumball, just make sure it's enabled here, because if it's off, you'll still be able to select the object, but no gumball will show up. So I recommend always having gumball on. And then we've got record history and filter. We're not going to really use those for this modeling workshop series. Okay, moving right along. At the very right-hand side of the interface, you'll see it may be defaulted to this properties, but this is where some of our main sort of settings and layers can be found. In Rhino 7, it is by default in this sort of horizontal display mode. In Rhino 8, they decided to switch it up, and they have all these little icons vertically on the far right side. Now you can change that if you want to be horizontal. This little gear, it's kind of faint, it's our options. You can change that from this vertical, which is what Rhino 8 defaults, to the horizontal. Oh no, see, wow, way down here my gear is. I'm gonna put it back to horizontal. That's how I've learned it, and I feel like it's a little bit more intuitive. So right off the bat, you've got the properties. this will show you information about a currently selected object. For instance, if we go to this surface, we can select the teal surface by left-clicking, and you'll notice the properties for this object are displayed now. So it will tell you what type of object it is. It's a surface. It'll tell you what layer it currently is on, what kind of display color it has been assigned, and a bunch of other information. So this is mostly handy for quickly identifying a type of object and what layer it's specifically on. To the left of that properties tab is going to be our layers tab. So we'll click that. And here you can see these are all the same layers that were showing up on this little pop-up window. So this is the same information, just a little bit more details. So you've got these sort of primary layers, like the parent layers. Then you can have nested layers within that. So that's a handy way of organizing your projects. I can't stress enough how critical it is and how helpful it is to make your projects organized by layer. Make simple layers that you know and understand, and label them, so that you can easily find different objects later. We'll go through that in a little bit more depth, but I really the more organized you are here, the easier time is going to be later. So that's our layer names, our layer sub-objects. You can toggle that little drop-down arrow to see all the other sub-layers of a parent layer. And then if you see towards the right on this header, it's the current layer. So you can change current layers here also by just clicking kind of in this little area under the header, and that little check mark will just indicate I'm changing my layer. So a quick way to do that. And then you can turn an entire layer on and off by clicking this little light bulb. Now, you cannot turn off a layer that you currently have on. Well, here, let me explain that better. If the layer that is assigned your current layer is the layer you're trying to turn off, Rhino won't let you do it. See, it'll pop up this cannot turn off parent layer of current layer. So you just say, if I wanted to turn off these sample objects, which are these guys over here, I would have to make my current layer a different one. So I'll just make it this one. Now I can turn off this other layer just by turning off that little light bulb. You can also turn off sub layers same way. Cool. To the right of that, the header is the lock layer, lock header. And so you can lock a whole layer and it will prevent you from selecting or editing or doing anything on that layer until you unlock it. So if you can't select something, check that it's not on a locked layer, right? That's one of the things that can throw me off sometimes. So lock and unlock. And then you've got the layer color, so you can change if certain objects on that layer are a different color just by clicking that box icon. So we can change this box layer to perhaps, I don't know, perhaps a sort of pinkish, I don't know, it's sort of a beige, I don't know. It's totally up to you. You can create a custom layer in this little wheel and really precisely adjust all those different colors if you have a specific one in mind. I'll just toggle it back to that cyan for now. Alrighty, and then other layer type surfaces that can, or rather, other settings that you can apply to that entire layer are things like materials, line types. We're really not going to get into much of that. So primarily, it's just whether you're creating a new layer here. You can do that quickly by going up to this new layer icon. It's slightly different in Rhino 8. Or a new sublayer. If you're on a parent layer like this, then you can create a new sublayer under that fairly quickly. This would be new sublayer. Or if you wanted to create a whole new higher level layer, this would, oh goodness, this would actually default in there. I think you have to select top parent layer and then new layer. See there, it bumps it out. New parent layer. Make sense? You can delete a layer by selecting that layer and then going up to this delete. You can Also move layers up and down in the order here using these little arrows, just if you want to rearrange them. It doesn't have a whole lot of effect on your modeling, mostly your ease of access on how you're seeing them in the layers. Great, I'll just delete that. I don't need that no more. Okay, so one other thing I would highly recommend is having this help layer up. Rhino is really good about being active in your sort of modeling workflow. So this help, if the auto update box is enabled, any command that you type into the command line, the help for that command will automatically pop up. So for example, if I type in line again, press enter, it will go to the line commands help section, and it gives you a whole lot of information about what this tool does, what the line command does. The line command draws one line segment. Oh, fantastic. The steps for that command. Step 1, pick a start point. Okay. Step 2, pick the end point. Super good. And then you left click through that. So there's a lot of helpful information that you can get. And it's really like you can go down a rabbit hole sometimes. There's quite a lot of info here. At the very end, you'll usually see related commands like lines. It's different than just singular line. And sometimes they'll even give you a little like video walkthrough. And if you scroll way down, it'll also give you a little like see also lines and curves. Sometimes it'll go to a Wikipedia article about tangent, apparently in this case. So anyway, the help command can be very surprisingly helpful. I use that fairly often when I'm not sure of the steps for a command or what a command even does. That's a very helpful place to go. So if that tab is not there, go to your little gear icon and just make sure under the list of things that can be displayed in these little panels, make sure the help tab panel is checked. So that's just to make sure that's there. Alrighty, so I believe that is our general tour of our Rhino interface. We're going to talk now a little bit more in depth about some of this geometry that we've got here. So let's zoom in here, and we can hold shift and right click to pan, sort of reorient in this area. We'll also talk about our sort of first command, I think, other than line that we'll use. Go ahead and if you click and drag a window, you'll see this sort of like window that starts to form. This is our selection window, and we'll talk a little bit more about that. But for now, just kind of go ahead and select some of these curves. It doesn't have to be all of them. And we're going to type in our first main command that I'd really love you all to remember and use frequently. I use it all the time. It's going to be ZS. And this is the abbreviation for zoom selected. This is just a really quick way to reorient your camera. So ZS with some object selected and then enter. And that will zoom and kind of reset the camera to whatever you're currently selected. Super handy. You'll notice, for instance, if I've zoomed out and I've kind of panned and I've done a lot of like orbiting around here, if I try to then like zoom into a specific object way over here, sometimes my zoom will get real funky. And then if I try to orbit, it gets real kind of out of whack. So to reorient your camera to whatever you want to be looking at, select the object that you're trying to reorient to, zoom selected, ZS, and then enter. And then that just reorients your camera so that it's nice and centered. Anyway, I use this so much that I've mapped it to one of my mouse buttons hotkey. So zoom selected, enter. Okay, so we're going to talk about curves here. We already talked about curves a little bit, but in Rhino, the terminology curve applies to any of these types of curvatures. So it could be a straight line, a two-point line. It could be a polyline, a series of straight lines connected together. It could be an arc, ellipse, a circle, freeform curve. So in Rhino, curves applies to all of that. So if you hear me referencing curves later and it's like a single straight line and you're like, wow, what is Keenan talking about? That's just how Rhino terminology works. So I'll try to do my best to explain those if we're talking about two or more of these objects. But anyway, so yeah, so these are curves, right? They can be in a plane like this one on the bottom here, or they can be in a 3D space, kind of going through in multiple axes. So that is different types of curves. Surfaces, like we talked earlier, are just those interpolated 2D membranes. I'd say they're 2D because they have no thickness. They're infinitely thin. So while they might be moving in 3 dimensions, they have 0 thickness. So these are 2 types of surfaces. They're the same surface. They're both called surfaces. They're just 2 different colors here. Just undo that little move. And they can be created in a variety of ways. In this case, I was using some of these 2D lines to form a profile for this to be created. We'll get into how to create geometry a little bit later. Our next type of geometry is called an open polysurface. These are one or more joined surfaces. So if we had joined these 2 together and created this output, this would be considered a polysurface, more than 2 surfaces, right? And it is open because it currently does not have, it is not enclosing a volume completely with surfaces. Our next object is, though, this is called a solid or closed polysurface. And my kitty cat's walking across my keyboard. So if you see this surface, if you select it, if you go to our Properties tab, you'll see that it is indeed a closed solid polysurface. Now we can kind of see how this changes by selecting the open polysurface, this object type, open polysurface, right? We'll care about this as we go. There are certain commands and operations that only work on solid closed polysurfaces, and some that work easier on open polysurfaces. So it's just helpful to know these 2 main types of polysurfaces. You've got your open and your closed, right? Now, this is our first sort of advanced feature that I'd like to show you. Being a surface modeler, Rhino does not create solid objects. What do I mean by that? So this might appear to be a solid, surface. It's completely enclosed, but it's a bit of a misnomer because if we were to take this apart, we would see that it's actually hollow on the inside. To do that, this is our first advanced command, and it's really just a keyboard shortcut. We're going to press Control and Shift at the same time, or if you're on a Mac, it will be Command Shift. And then we'll left click this top surface here. Now that will allow us to select just this top surface of the polysurface, because otherwise if we just left click like a plain left click, we'll select that entire surface. So this Control Shift click is a very powerful way to select sub surfaces or even the edges of surfaces in a really quick, easy way. So with that surface selected, I'm going to press the Delete key or backspace if that's the key your keyboard uses, and then it will delete that top layer, and you'll see it's completely hollow on the inside. So and now if we select it, we'll see it's an open polysurface. Okay, so that's just a demo. Let's just undo that, Control Z or Command Z if you're on a Mac. So that's just a demo that while Rhino does call these solid closed polysurfaces, because it is a surface modeler and not a solid modeler, you're still going to have hollow objects. And you can see that also by zooming way in. Eventually, your camera will pass through the surface of that object, and you'll kind of be inside it, and it's kind of trippy. But that's another way to sort of see that, okay, yeah, these are hollow surfaces. They're closed, they're sort of watertight, quote unquote, if you will, but they are surfaces nonetheless. Alrighty, moving right along. Here are these 2 other surface types, right? These are more like sort of abstract topography examples. Open surface, and then a closed polysurface. This is just a single surface, right? All right. So we have some other types of geometry. These are called lightweight extrusion objects. And these are only it's a fancy word for saying they're simple shapes, right? This is the same type of stuff that is created with the box command that we saw earlier on this toolbar. So if, for instance, if I click that command, left click to activate it, this is a good kind of initial demo of a basic command. So left click to activate. Up in the command line, it'll prompt you for the next step in the command. So first corner of base, I'll just click once to define where my starting point is. Now the command has changed other corner of base or length. So you could also enter a specific length on the keyboard. For now, I'll just click sort of randomly over here. And then the final step, the height, or press enter to use the same value as the width. I'll just sort of arbitrarily left click over here. So that's how you would create a simple box. And that is a lightweight extrusion object. It's a very simple way of defining a volume. It's a profile, a distance, and a direction. So you can also, I'll just delete that, don't need it right now. You can also create these lightweight extrusion objects by creating a line and then using an extrude command. And these are similar ways. So you can create like either very straight sort of segmented things or sort of very curvilinear shapes, same way. And these are some of the other like these prisms or like this sort of ring, cylinder, other types of objects. Super handy. These are great starting points for a lot of things that you can kind of add on to and sculpt with later. Alrighty, moving right along, we've got meshes, talked about these earlier. So you can create meshes in Rhino. You can also import models that are meshes. This is another type of modeling software, is a Blender, and I believe SketchUp might also use meshes. So you can import those in Rhino and you can still manipulate them. They're just harder to work with and less precise. So they have their place here, but definitely not by default. And here's a fun little Pokemon. This is a Bulbasaur model. You'll also find meshes on a lot of 3D printing libraries. So meshes are perfect for 3D printing. In fact, you usually have to export from some software to a mesh. So this was a little model I found online, and you can easily 3D print meshes. Okay, other objects in Rhino. We've got points, so these little tiny point objects, they just have a XYZ coordinate and there's no dimension. They're just represented by this little white dot. Can be helpful. I don't use them all the time, but can be helpful. Another type of point object is a point cloud. So you see this sort of cluster of dots over here. If you select that, it's actually a whole group of a point cloud. And it's a little hard to tell because they're so small, but they are in 3D space. And a point cloud is a sort of a relationship, a cluster of these points that are all related to each other. I often never use these. So like I never use these. These can be generated from other types of scanning software like LiDAR. Some fancy firms and architectural practices use LiDAR scanners to get as-built conditions, or if you have a drone that creates a LiDAR scan, sometimes you'll have billions of these points that define a volume. So Rhino can do stuff with them. Truly uncommon in my workflow, just so you know that they exist. Other types, so we've got lights. So as we saw earlier, let's go back and change our DisplayPort view mode to this rendered view mode. So you'll see now with that light selected, it becomes invisible in this mode. So you have to go back to shaded mode. But with it selected, and then you can use the gumball to kind of move this light around. You can see this is a point light, so it's just a single point, creating this sort of shadow area. So that is another type of Rhino geometry, point light. I'll go back to shaded mode. And they look like this in shaded mode. They tend to disappear in any kind of rendered viewport, so just keep that in mind. Other types of objects, we have dimensions. So you can annotate your drawings with a dimension command. have leaders, so you can say, oh, this is a point light. So those are other types of objects. All right, so I think that for now, that will cover our basic intro to the Rhino. What is Rhino? Where it fits in. I suppose I should talk a little bit about where does Rhino fit into a design workflow? I imagine Rhino as sort of this bridge between conceptual design, where you're just really getting your raw ideas generated. And that could be from multiple ways, right? It could be that you're creating sketches in a sketchbook, watercolors, collages, photography, whatever your initial brainstorming kind of ideation process is. So it's a bridge between that and more technical drawings like construction documents or building integrated modeling, BIM modeling, right? Rhino's very good at bringing your conceptual ideas to life in precise ways that, the level of precision can vary depending on what you're needing. Rhino is super powerful at creating complex geometry with relative ease, and it is unmatched in the way you can manipulate that and represent that geometry. So it is fantastic. It's highly flexible. So if you're using simple forms to create very orthogonal objects, it can do great at that. If you're using complex geometry that has a lot of curvature, it's also great at that. It can do multiple scales, so you can model in millimeters. I do a lot of that for 3D printing. Or you can model in kilometers, or I've even seen light years as a unit of measurement. So it is very flexible in scale, scope, and application. It's also very good at representing and rendering out your ideas. And so I hope this sort of gives you a basic introduction to some of the types of tools that you can use Rhino for, and what types of geometry Rhino's good at and what it's not good at. So it's not good at creating final construction documentation. It's not going to be as smooth as AutoCAD for that 2D line work. It is also fairly niche, while it's used a lot in architecture and design, landscape architecture and design, industrial design. Not a lot of consultants, engineers, civil engineers, they probably don't use Rhino on the day-to-day. So sharing files that are in Rhino is possible, but I don't think it's as widely used in those types of applications. So, and it is definitely not for BIM. It is, while you can do construction documentation in this, it's just not set up for that level of coordination. It does, Rhino does interface with other BIM modeling programs like Revit. There's a whole plugin that Revit and Rhino have developed together. It's called Rhino Inside Revit. And there are ways so that you can get a Rhino model to talk to a Revit model in smart ways. But that is all, I think, outside the scope of our workshop. But just wanted to give you a broad overview of where does this fit in? So it's that bridge between concept and more precise drawings. And it's also a really great way of representing your ideas. So I hope this helps give you a basic rundown of Rhino. We're going to get into a few other sort of basic commands and how do you move objects, how do you sort of navigate that early steps in the next video. Thank you so much, and I hope to see you in the next video. Happy modeling.